Now we are going to start with an important phenomena, that is the surface tension. See, suppose I have a beaker and I have water in it. So if we talk about the definition first, surface tension is force acting along the surface per unit length, or you can say force acting per unit length along the surface is called as surface tension. See, what happened here is, first I am going to explain you the cause, then we will come to the main point, that what is surface tension. Suppose if I consider this is a beaker and I have water in it, let us consider a water molecule here. So we see that on this water molecule at point A, let us say this is point A, we see that at point A, if we consider a molecule, then this molecule is being attracted from all the sides. There are cohesive forces. We know that, I told you that cohesive forces is the forces that operate between the molecules of same kind. So we see that this molecule is being attracted from all the sides, but all the forces being equal and opposite cancels out, and there is the net force acting on it is 0. Now let us consider a particle here at this point, let us say this point is B. So we see that the particle which is present at the top, that means on the upper surface, on the upper free surface, it is being attracted by the particles present below it, from this side, from this side, from this side. But there are no forces from this side, but there are no forces from upward direction. That means all the forces are from downward, but there is no force is here from the upward which can balance it. So that means it will experience a net force, and net force will be a downward pull, and the net force will be a downward pull. But so you can say all the molecules which are present on the surface, on the free surface, they will experience a net downward pull. But what they do actually, they are like, because they are exhibiting a downward pull and there is no other force acting on the upward which can actually balance those forces acting in a downward direction. Therefore, these molecules try to come closer to each other. Therefore, these molecules try to come closer to each other. And when they come closer, they occupy the less surface area. They occupy a less surface area, or we can say that they appear to be a stretched membrane. The upper free surface appear to be a this is, I am talking about only for the upper free surface. It appears to be a stretched membrane. So this phenomena is called as surface tension. Again, I am going to explain you what is surface tension. Obviously, it is a force acting along the surface per unit length. Now, how due to the surface tension, what we see actually, or you can say that what is the condition necessary for the surface tension to occur? The condition necessary for the surface tension to be seen is that there should be a free liquid surface. There should be a free liquid surface in contact with the air. It is only seen in this case. The surface tension is seen when the free liquid surface is in contact with the air. As you can see that this is the liquid surface and this is the air around. So that means here the surface tension exhibit. So what happens, like due to surface tension, the upper free surface, only this surface, this one, it appears to be a stretched membrane, and like it appears to be a stretched membrane, and due to which the molecules start coming closer to each other. They occupy less surface area. They try to contract actually, occupy a less surface area. And what is the cause behind? The cause behind is that the molecule which is present here is being attracted by the molecules, cohesive forces acting on the molecule, because you should know that what nature of force is acting. Cohesive force is acting on this molecule, but the forces are acting only from the downward side, as there is no molecule present up, so there is no force from the upward which can actually balance the downward force. But in contrast, if we see that the molecule which is present in a bulk is being attracted from all four sides, so that means the net force is 0 and it remain as such as it was present earlier. But here, as it is exhibiting a net downward pull from inside, so just to balance that, they will start coming closer to each other and they appear to be a stretched membrane. So this is what is the surface tension, and this is the cause you are going to explain. Now you know that if we talk about due to the surface tension only, we see certain phenomena, like we see that whenever you can say a spherical drop, like a liquid, when it if a liquid is dropped on a table or something, it like if you spread a liquid on any glass surface or anything, they try to acquire a small spherical drop. It becomes a spherical drop actually. So you know that the spherical drop is actually like the shape, like you spread, earlier it is spread like this is certain glass, so you spread any liquid, so it is spread like this, but in few minutes what you see that they acquire a droplet like structure. So they appear to be a spherical droplet. This is just due to a surface tension. As I told you that there exists a surface tension, there exists a more cohesive force, therefore they try to contract and acquire a least surface area, and the least surface area we know that is a spherical shape. That is why the spherical drop, like why the drops become spherical, just to reduce the surface tension, like because when they acquire a small area they just reduce the surface tension and they start coming closer to each other, and they acquire a spherical shape, and this is merely due to the surface tension. Likewise, you have seen that we will discuss one more thing, meniscus. Meniscus of liquid, what is that? Meniscus of liquid is that, you can see that this meniscus of liquid, when any liquid is in contact with solid, any liquid is in contact with solid, then you can see the meniscus actually. I will tell you how. Suppose I have a glass tube like this and another glass tube like this, in which in one I am pouring water. In one glass tube there is a water, and in the other glass tube, let us make it with green. Do not think that mercury is green in color, just drawing in order to differentiate it. Let us say that this is mercury. So if you put a mercury and water in two different tubes, you will see that the point where the liquid and the point where this liquid and solid comes in contact with each other, there appear a slight depression or a slight curve like structure. We can see like the point where it comes in contact with this point I am talking about. So at this point where the liquid comes in contact with the solid, it tries on the upper surface, it tries to acquire a curve like structure. And two kinds of curve can be seen. A curve can be seen like this, or a curve can be seen like this. So two kind of curves are actually seen. So if you put water in glass, you see this kind of curve, and this is something called as concave meniscus. And this kind of this kind of curve is seen in case of mercury, and this is called as convex meniscus. Now I think you got it, that what is the meniscus? Meniscus is that surface, that the upper surface where you can see the curve where the liquid comes in contact with the point of contact of liquid with the solid, there appear a certain curve like structure, and that is called as meniscus, the upper layer. So we see that meniscus merely of two types. One is concave, like you have seen in water when put in a glass, and the other type of meniscus is this, that is the convex, where you are seeing a bulging kind of portion. This is a inward depression and this is a outward extension. So this kind of meniscus is there. Now what is the reason, as both water and mercury are liquid, but still we can see different kind of meniscus? The reason here again is based on the force of cohesion and adhesion. As I already told you that cohesion force is the force that exists between the molecules of same kind. That is the force which exists between the water molecules, the force that exists among water molecules is the force of cohesion. And the force that exists between the water and the glass molecules, that means the liquid and the solid molecules, is the force of adhesion. If we talk about the nature, both the forces are attractive in nature. Same way in mercury, the force that is existing between the mercury molecule is the cohesive forces, and force that is existing between the mercury molecules and the solid, that is the glass, that is the force of the adhesion. Now what happened, like if we talk about water, we see that here in this case adhesive forces are more strong. Adhesive force is much strong. So that is why the meniscus appear to be a inward depression, and in this case the force of cohesion is quite strong as compared to the force of adhesion. Therefore you can see the meniscus like this. So this is the reason that you get a concave meniscus and you get a convex meniscus. So you need to answer like this, that meniscus is the upper layer, and when a solid is put into a liquid, then at the point of contact there appear a curve, and that is called as meniscus. We can see that curve, that is we can actually notice that curve is may have an inward depression or an outward bulging. So inward depression means concave meniscus and outward is the convex meniscus. Concave meniscus is just because here the force of addition is less as compared, force of addition is more as compared to the force of cohesion. That means the force between the water and the glass is much more. The attraction is much strong as compared to the force that is operating between the water molecules. And here the force of attraction between the mercury molecules is quite high. That means adhesive forces are, cohesive forces are much stronger than the adhesive. That is why the meniscus appear to be convex. And as I told you that one of the evidence is the spherical drop of the surface tension. So this I may explain you, like suppose I say that I take a glass and I just pour a mercury on it and I just pour a water on it. After some time I will see that mercury, you can say the mercury will acquire a small droplet kind of structure, and the water, it remains scattered like that, means it is just poured as we have poured earlier. So this is because that in mercury the force of cohesion is much more stronger, therefore it tries to come closer to each other and acquire a spherical drop like structure, but it does not happen in case of water, because in comparison to water, as I told you, that force of adhesive is more as compared to the force of cohesion, therefore it remains scattered like this. So this is what is the surface tension. Now if you talk about, see, water is the liquid which has a maximum surface tension, which we see actually. But if you add certain substance into water, like you add salt into water, you add sugar into water, so this will, like adding any molecule into water is going to lower the surface tension. So one thing you need to remember is that, like when you add anything into a water, so that means the surface tension gets lowered. Second is that if you increase the temperature, they will start moving away, so that means they won't appear to be much closer to each other. So that means surface tension will decrease with increase in the temperature. So this is what you should know, that what actually is a surface tension. I think you got it. So coming on to its unit, so as it is force per unit length, so obviously SI unit is going to be Newton per meter. And if we talk about the CGS, obviously force is in dyne and length is in centimeter, so it is dyne per centimeter. So I think you got it, that what is the surface tension and like what you see due to surface tension and what is the cause actually. And if we also talk about the evidence that which shows that there exists a surface tension, or you can say the consequence that due to surface tension what kind of things you can observe. And we have already discussed the meniscus also, why the concave meniscus is there for certain liquids and why the convex meniscus is there, just depending upon the force of the cohesion and the addition.